Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Step 1. Structure of o-Xylene and its double bonds. O-Xylene is 1,2-dimethylbenzene. The benzene ring has 3 formal double bonds. In one kcul structure they are at positions 1 to 2, 3 to 4, and 5 to 6. In the other they are at 2 to 3, 4 to 5, and 6 to 1. For ozonolysis purposes, we consider all 3 double bonds of the ring being cleaved. Step 2. Numbering and labeling carbons. Label the ring carbons 1 to 6 with methyl groups at C1 and C2. The 3 double bonds in one kcul form, C1 is equal to C2, C3 is equal to C4, C5 is equal to C6. In the other kcul form, C2 is equal to C3, C4 is equal to C5, C6 is equal to C1. Step 3. Products from ozonolysis, reductive workup with Zn. Each C is equal to C bond is cleaved to give 2 carbonyl fragments. The substitution at each carbon determines whether the fragment is an aldehyde, ChO, or a ketone, C is equal to O with 2 carbons attached. C1 bears a methyl group upon cleavage gives a CH3, C is equal to O, fragment, ketone end. C2 bears a methyl group upon cleavage gives a CH3, C is equal to O, fragment, ketone end. C3, C4, C5, C6 bear only H upon cleavage give ChO fragments, aldehyde end. Step 4. Possible decarbonyl fragments from the ring opening. Since the ring is cleaved at all 3 double bonds, the ring opens to give a single open chain hexanediol type compound, which then further fragments. The adjacent carbons in the ring that are connected give the following paired carbonyl units. From C1 is equal to C to cleavage, CH3, CO, vertical bar, CO, CH3 diacetyl, option C, is possible. From C1, C6 and C2, C3 region, CH3, CO, vertical bar, ChO and CH3, CO, vertical bar, ChO methylglyoxal, option B, is possible. From C3 is equal to C4 and C5 is equal to C6 cleavage, OHC, vertical bar, ChO glyoxal, option A, is possible. Step 5. Evaluating option D. Option D is CH3, C is equal to O, C is equal to O, ChO, a compound with a methyl ketone, a second ketone carbonyl, and an aldehyde on the same 3-carbon chain, i.e., 2,3-dioxobutanol or 3-oxobutanol type. For this fragment to form, we would need a carbon bearing a methyl group directly bonded to a carbon bearing only H in the ring, and that second carbon would need to be bonded to another carbonyl carbon that is also adjacent to another ChO. Tracing the ring, C1, CH3, C2, CH3, C3, H, C4, H, C5, H, C6, H. For the fragment CH3 CO, ChO, we would need C bearing CH3 adjacent to C bearing CH3 adjacent to C bearing H cleaved in a specific way, but since C1 and C2 are both methyl bearing, the C1, C2 cleavage gives CH3 CH3 not CH3 ChO. A fragment CH3 ChO would require a methyl-bearing carbon adjacent to another carbonyl carbon that is adjacent to an H-bearing carbon in a single fragment, which is not consistent with the connectivity of o-Xylene. The fragment would require the same carbon to simultaneously be part of 2 different cleavage products, which is not possible. Thus, option D cannot be obtained. Step 6. Conclusion. Options A, B, and C are all legitimate ozonolysis products of o-Xylene. Option D, CH3, C is equal to O, C is equal to O, ChO, cannot be obtained because no such connectivity exists in the o-Xylene ring that would produce a 3-carbon fragment with methyl ketone, internal ketone, and terminal aldehyde simultaneously. Therefore, the correct answer is D. Therefore, the correct answer is option D.